Okay, so this is our first lesson. Section 10.4. These are called inscribed angles of a polygon. So our objective today is to find and use inscribed angles of polygons. To find and use, oops, bad pen. Oh, sorry guys. Try to zoom in a little bit, but then, okay. Find and use inscribed angles of polygons. We're going to go ahead and skip the warm-up here. And so our first definition is an inscribed angle is an angle whose vertex contain chords of the circle, and the vertex is on the circle. So the last one that we actually talked about together, the vertex of all of our angles were here at the center. Now these are on the circle. So if you look at the vertex of that angle, it's on the circle, and then it has the two chords that go through the circle. So the arc that lies in the interior of an inscribed angle is called an intercepted arc. So basically, if you follow out these chords and you keep going and you follow both of these out, whatever arc lies between them, so this arc is what we're calling our inscribed angle. So the measure of this angle down here is always going to be half of the measure of the intercepted arc. So for example, if this arc, let's say, was 60 degrees measure, then you just take half of that, and this angle down here would be 30 degrees. Okay. The other thing they'll do sometimes, they'll give you the angle measure. So if I said this is 20, to get the arc, you would just double it and say it's 40. So if we look down here at example 1, it says find the indicated measures in this picture. Okay, so it looks like we have a little mistake up here. Let's just say this one was asking for angle S. Let's go with that. So angle S is right here. And so if the vertex is on the circle, I know that my angle is going to be half of the intercepted arc. So my intercepted arc is 60. This angle would be half of that. And so my intercepted arc, or angle, sorry, would be 30 degrees, my inscribed angle. Okay? On the other side, they want you to find the measure of arc RQ. So from here to here. All right, so this part is just a tiny bit tricky because this angle, if I follow it out, so here's an angle right here. If I follow it out, I know this angle measure is 37. So I know that I can find this arc right here. So if the angle is half the arc and my angle is 37 degrees, right? How am I going to find my arc? And I know some of you will do this part in your head, which is fine. You're just going to double it. So you're going to multiply it by 2. Okay, so that arc over there is going to be 74 degrees. It's going to be this particular arc, right? But that's not the one they asked for. They asked for this dotted one up here. Do not forget about your diameters of your circles. So what do we know about a diameter? We did this in class together. It creates 2 semicircles, which are 180 degrees each. So if I want to find this arc that they wanted, I'm going to take 180. Whoops, I'm going out of the... Uh-oh, sorry, I'll do it up here. 180 minus 74. And so we know that our arc here is 106. All right. Okay, so let's move on to example 2. All right, so when I kind of come across a picture like this, I want to think about, okay, what do I know? Well, here's a vertex on the circle. So I know that this angle right here is half of its intercepted arc. So 12x is half of what that arc is. So if I want to get this arc, I'm just going to double 12x. Sorry, my nails are awful, aren't they? So if I double 12x, this is going to be 24x, right? And then this whole circle, all the way around a circle, is 360 degrees. So I'm just going to add up 125 plus 24x plus 115, and I'm going to set it all equal to 360 degrees. All right, so if I combine some like terms here, I get that 24x plus 240 equals 360. Subtract 240 from both sides, I get 24x is 120 and x is 5. And I know this was weird. Should have said solve for x. So in this particular problem, that is our answer. Okay. Now we're going to go along to page 2, which starts off with theorem 10.8. So it says if two inscribed angles of a circle, so the same circle, intercept the same arc, then the angles are congruent. This only makes sense because an angle, so here's an angle, right? So it intercepts BC, yes? So we know that this angle A is half of BC. Well, if you come down to D, it also intercepts the same arc BC. So that means that, oh, you couldn't see any of that I was doing. So sorry. Just realized that. So this angle A, if you follow this out, it intercepts arc BC. And this D intercepts the same arc. So even though we don't know the measure of this arc, we know that A is half of it. So angle A is half of arc BC. And we also know that angle D is half of arc BC. Oops, that goes up there. So by the transitive property, we know that A and D must be congruent. And then if they're congruent, they're equal. Okay, so on this one, I want us to find the measure of angle C. I don't know why those are not on your paper. That's kind of weird. They didn't print on mine. So I don't know if they're going to show up on yours or not. So measure of angle C. So what do we know about the measure of angle C? Well, here's C. If you follow it out, it intercepts this arc. If you follow out B, it also intercepts this arc. Okay, so what we know is that B and C are the same. So this is a 3n. I don't know if that's hard for you to see. So I know my angle is half of my arc. So I'm going to say 3n, sorry, is half of 160 minus 10n. Now, obviously, at this point of your algebra, you've got some options. If these are even numbers, it's easy to take half of even numbers, so you can just distribute the half. Or, obviously, you can multiply both sides by 2. Since they're even, I think I'll just distribute it. So that's 80 minus 5n. Add 5n to both sides. 8n is 80, and n is 10. Now, remember, they didn't ask for n, they asked for the measure of angle C. So I'm going to go back up here. I know that it's 3n, so you just do 3 times 10. So that would be 30 degrees, would be your final answer. Okay. Okay, so moving down into these theorems, a polygon is an inscribed polygon if all of its vertices lie on the circle. The circle that contains the vertices is called a circumscribed polygon. So we can, like if we do 1, 2, 3 points all on the circle and we connect them, this would be called an inscribed triangle. Okay, we can also do 1, 2, 3, 4 and connect all these. And this would be an inscribed quadrilateral. So inscribed triangle, inscribed quadrilateral. For our next theorem, if a right triangle is inscribed in a circle, then the hypotenuse is a diameter of that circle. So So let's kind of draw that out. If a right triangle is inscribed in a circle, so remember a right triangle's got to have a right angle. So if it's inscribed there, then that tells me that this piece right here must be a diameter. Even though we don't have like a center of a circle or anything drawn on here, this theorem says if a right triangle is inscribed, the hypotenuse must be the right angle. I mean, my daughter's distracting me. She doesn't think you can see very well. She's worried about you. Oh, the word diameter. Yeah. I got you. Okay. Conversely, if one side of an inscribed triangle is the diameter, so if they show you it going through the center of the circle, then you know that's going to be a right triangle. And this is a weird one. This one always tricks people. So it says if a quadrilateral can be inscribed in a circle, if and only if, that means this goes both ways, if its opposite angles are supplementary. Now, what have we been studying all this time about parallelograms? We're always like, opposite angles congruent, opposite angles congruent. Well, in this, if you're able to inscribe a quadrilateral inside of here, the opposite angles are actually going to be supplementary. So A plus C is going to be 180. You see that? And B plus D is going to be 180. Kind of a weird new theorem. All right, so on this back page, we just have a few examples, okay? So right away, I see this, I notice this point right there. And so that's showing me, oh, that's the center of a circle, which tells me this has to be a diameter, because diameters go through the center. Once again, this should be on here. Find the measure of angle C. I don't know why that's left off. So because a diameter is a part of this inscribed triangle, what do I know about it? Well, I know it's a right triangle. So if that's 90 and this is 50, then we know that angle C has to be 180 minus 90 minus 50, which is going to be 40 degrees. This one wants you to find the value of X and Y. Find the value of X and Y. So this is a tricky one. This is an inscribed quadrilateral. So what do we know about those opposite angles? They're not congruent anymore. If it's an inscribed quadrilateral, the opposite ones are supplementary. And so then you would have 8x plus 4x equals 180. So this is 6y is 180, y is 30. And 12x is 180, and you divide both sides by 12, and x is 15. So only on the inscribed quadrilateral, opposite angles are sup. All right, so if you look at this one, find the values of X and Y. It looks like this one's gonna make you set up a system of equations. So we have 10X, so working from this angle and that angle, plus 16y plus 6 is 180. And our other equation is 4 plus 18y plus 10x minus 6 is 180. So remember, a system of equations is when we have two different equations, they both have two unknowns. So our options for solving are substitution or elimination. Okay, substitution tends to work well if you have a letter or variable that's by itself, which I do not. So in this one, I'm going to use elimination, but you really want to make sure you get these into standard form. That means X and Y are on the left side. 10x plus 16y, but I'm going to move the 6 by subtracting it and say that that equals 174. And then I'm going to come down here and clean up this equation. So my x's and y's are out of order, so I'll put my x in the front, y behind it. Make sure you get your signs okay. This is 4 minus 6. So over here I've got a negative 2 going on. So I'm just going to add that over here to the other side to make 182. So now I'm going to line these up underneath each other. And actually, if you notice, well, I guess I'll just write it up here. So this is how you do elimination. Okay, and you need opposites. So these are really close, 10x and 10x, but they're both positive. So if I were to draw my line and add together, that would make 20x. So I'm just going to take this top equation and multiply it by -1. So I get negative 10x minus 16y equals negative 174. Draw my line. Those eliminate. That's why it's called elimination. And this is 2y equals 8. Divide by 2, and y is 4. Now that's only one part of my answer because we needed to find the value of x and y. Sorry, that wasn't up there again. So how do we find the value of x? Pick any equation. I think I'll just go right here. It's kind of set up nice and clean for me. And I will plug in y is 4 into here. So 10x plus 18 times 4 equals 182. So 10x plus, what is that, 72 equals 182. So I'm going to subtract 72 from both sides. I get that 10x is equal to 110. And when I divide by 10, I get x to be, oops, sorry guys, x to be 11. So obviously it's so hard because I want to say any questions, but I can't really do that. It looks like for this one we have a worksheet for our homework. And so I will go ahead and scan this in. And I think we won't need to worry about the proofs. I'll just kind of show you. We're going to do this 10.4. I'll post a picture, right? Or scan it in for you. And on the back side, don't worry about the 2 paragraph proofs. Okay, so we'll just work through these problems. Looks like there's 26 of them. They will not be due until tomorrow morning. And we'll just say 10 o'clock to be fair. And start that off for our first assignment. All right. I hope everybody's well. I'll be back soon.